Hello all, today in this video I am going to provide a demo for adagrad optimization algorithm with the CNN. Previously with the same CNN algorithm we have worked with different optimizers, and now we are going to work with adagrad optimizer and going to make a comparison that which optimizer algorithms in CNN is providing better results. For that, initially we are importing the libraries which we are needed, then we are loading the dataset. This dataset we downloaded from Kaggle. You can just give us heart disease detection in Kaggle, means you will get this dataset. This dataset is having nearly 14 entries. Among that, the first 13 entries we will be using as the X variable, and the last entry, which is the target one, we will be using as the Y variable. Then we are getting the info of the dataset. From that, you can get to know that we are having nearly 14 entries, which is 0 to 13, and from that you may notice that old peak is only the float integer type or float type, all others are integer type. And then we are getting describing the data set, and we are there checking whether our data set is having any null entries. Why? Because if our data set is having any null entries, means we have to work with any pre-processing function. Since our data set is not having any null entries, we have omitted this pre-processing. Then we are displaying the heat map of the data set. So this is the heat map of the data set. Then we are describing the X variable and Y variable as I mentioned previously. Within X variable, since we are using the all variables excluding this target variable, we are dropping the target variable and using all others as X variable. Then within the Y variable we are using only the target. Then by use of this X variable and Y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training, we are determining variables like X train, X test, Y train and Y test. Then we are determining the standard scalar which is used to convert into vectors. For this we are using the variables like X train and X test. Then we are getting the shape of X train and Y train. Why? Because this CNN will works with only with three-dimensional input, and also we have to take the shape as the input within the CNN layers. For that only we are getting the shape. But if you notice, we are not having three-dimensional data as input, so we have to convert our data into three-dimensional. So we are using the reshape function. It is meant to convert our data into three-dimensional. You may notice that initially our shape of the data is this one, two-dimensional, and now it has become three-dimensional by using the reshape function. Now we are describing the layers of the CNN. The CNN consists of sequential layer followed by the convolution layer, which determines the filters, kernel size, padding, activation and input shape, which is 13,1. Then we have given the quarks pooling layer with the pool size as 2, followed by the flattened layer. Then the dense layer with the output dimension as 128, activation as ReLU, then dropout as 0.5 and dense as 1. Why? Because our work is a binary classification work. In case of multi-class classification, we have to give this 1 as the number of classes we are having, and mostly in binary classification work we will be using the activation as sigmoid only. Then we are getting the summary of the layer description. Then we are compiling our model by using the compile function, and loss as binary cross entropy, optimizer as Adam, metrics as accuracy. Then we are training this model by using the fit function and the variables like xtrain, Y-train, validation data with X-test, Y-test and approaches for nearly 50 approaches. Here you may notice that when compared to this accuracy, validation accuracy is less. But for a better model, validation accuracy should be higher than accuracy. So we are taking steps to increase validation accuracy higher than accuracy. So before that we are plotting the model to just check whether training accuracy is good or validation validation accuracy good. But you may notice that only training accuracy is good. But for a better model, validation accuracy and validation loss should be only good. So we are moving to some other steps, and before that we are displaying the classification report and making a definition for confusion matrix and also plotting the confusion matrix. So the only difference we have done is we have reduced the dropout rate. Initially it is 0.5 and now we have reduced to 0.1. Now if you notice, means the validation accuracy is higher than the accuracy, you may notice. So by this model only we are working with other optimizers. Also we are displaying the classification report and also the confusion matrix. Now then we are working with SGD optimizer, or every layer composition and compiling, then fitting and all same only the difference is the optimizer. Previously it will be Adam, now it is ISGD, and we are working for nearly 50 approaches and got the classification report and also the confusion matrix. Then we worked with rmsprop, and in that case we just replaced the optimizer with the rmsprop, and then displayed the values for nearly 50 approaches and displayed the classification report and also plotted the confusion matrix. Then we worked with adadelta, same we have replaced the optimizer as adadelta, and it works for nearly 50 approaches, and we have displayed the classification report and also plotted the confusion matrix. Then in this work we have worked with adagrad. The only difference we have done is we have replaced the optimizer as adagrad, and we have worked for nearly 50 approaches, and we have got an accuracy of 81, which is less than Adam. So as of now Adam only is providing better results, and we have displayed the confusion matrix also. Then we are making a comparison of this plot by with every algorithms we have every optimizers we have done so far. From this you can notice Adam is the blue color one, and it is the one which is having the higher training accuracy, not training accuracy, and also validation accuracy is also high. Now first it is low only, but after that it is a high or same as that of this training accuracy only. But low in the case it is red color, it is ada delta. So now ada delta is showing the least accuracy. So same loss and validation loss. So this is the comparison of different optimizer with CNN. In the next demo we will be working with some other optimizer and will make a comparison regarding that. If you are interested in knowing some other demo video, means please let us know in the comment box. Thank you.